You don't think so?
Yeah, it's not solder bit. That's the other thing. Yeah, some of the cheaper ones. I don't remember which brand.
All right. Do you guys want to like say anything, or we just get going? All right. What do you think, guys? Should we get started? Everybody good with that? The game is still going. We'll know what happens based on your reaction. I've been checking nonstop myself. Right on. Are they in the 11th now? All right. Well, I guess thanks everyone for coming out to listen to a chat about API security. I got to meet a bunch of you all last time. Miriam let me crash this chapter event about a month ago, so thank you. And we're happy to be the sponsors of this session. So I'm Dan Barahona. I'm one of the founders of API Security University. I brought Jesse along, so he's my wingman. All the hard questions, you know where to send them to. And what we're going to do probably, I guess, the next couple hours is there's going to be a hands-on part. So if you brought your laptop, you'll be able to, get your hands on keyboards and try some stuff out. We have some new tools that we just launched like yesterday. So some pretty cool things. And what we're going to start though with something I call the API Security Workshop. It's something I've done literally hundreds of times. I kind of feel like a comedian who's got his material and it keeps kind of improving it, and it's pretty solid, I gotta say. Like, the jokes are not bad, but they're not great either, honestly. And so let's see if I can make this work. If you don't know AppySec University, is anybody familiar with AppySecU? You are? Right on. Sweet. That's, of course, we talked about it. No one. Oh, you were at the OC. All right. So sorry, this is going to be a little bit of repetition, but don't break. Don't tell any of the secrets. But yeah, no spoilers. No spoilers. But basically, this is a site we launched about 3 years ago now, and it was really, we just felt like there was a lack of understanding and appreciation of the risks that APIs bring, and how we've kind of been ignoring them, and it's been resulting in lots of breaches. So we created this site and we started making courses. The first one, let me get this thing out of the way. How do I make that disappear? At least shove it to the bottom. The first one we started with is API pen testing. This is our flagship course. If you want to learn like how to hack APIs hands-on, it's 12 hours. It's very meaty. It's really outstanding. A lot of people saw that and they're like, well, do you have like a more of an intro course? Ted, you were asking, like, this API security fundamentals is the place to go. I am the instructor on that, but it's 90 minutes. I don't know if Miriam, have you taken it? Yeah. It's a lot of like what we're going to talk about today, but it's a good intro. And we got lots more. There's, I don't know, a dozen, 15 different courses. They're all free. Everything's free, right? We don't charge for any of this. We're not in the business of education. It's not our business. We don't need to sell it. We have another business, which I'll tell you all about. It's appysec.ai, so different ending. And what we do is we make technology to help you secure your APIs, mostly through testing, right? So really comprehensive pressure testing of your APIs, right? For logic flaws, authorization, and that's what we'll show more about later. But we're over 100,000 students now, so this thing has really just exploded. So This workshop is kind of broken into 3 sections or 3 acts. The first is why do attackers love APIs? What makes them so appealing? How are they being attacked and breached? And by the way, anybody who wants copies of slides, I got my email at the end, happy to send them out. And then, and we're gonna cover the OWASP top 10 in the process. And then, what are best practices for keeping APIs safe and secure? And then I'll be done, and then Jesse's gonna show you actual live testing and evaluating APIs. I'll give you a little demo of our new tool as well. So that's it. I always like to start with kind of a Hollywood, like you got to grab the audience right up front, right? So here's my opening scene, right? So it's Coinbase. Imagine you're researching, right? And you're like, I want to poke around on Coinbase and see if I can find any flaws, right? So Coinbase, it's where you buy and sell crypto, stuff that I don't do and don't understand. So there was a hacker researcher and they poked around and they did what hackers do. They created an account. They started trading and watching all the traffic between their browser and the back end. And this is what the traffic looks like. Try not to get in the way here. Well, I guess you got a choice of monitors. This is what the traffic looks like when you do a trade, right? And here you got in yellow the parameters. The base size is the quantity, the price. The product ID is Ethereum in euros. That's what they're selling. And then you see their account information, right? It's totally legitimate request. But one of the things attackers like to do is send erroneous requests to get error messages back, because sometimes our error messages are not just helpful, they can be revealing, right? It might say like, expecting an 8-digit integer, or it might reveal what kind of database is running. So in order to get an error message, he backspaced over the Ethereum, which he owned, and he wrote Bitcoin, which he did not own. And he hit submit and waited for the error message. Anyone want to guess what the error message said? Sorry? Nothing? No, not nothing. It's a trick question. He didn't get an error message. He got a trade confirmation. And his $1,000 of Ethereum sold as $43,000 as Bitcoin, right? And it actually worked, right? It's like having tinfoil and selling it as platinum, right? And it actually worked. He must have been absolutely shocked, right? Probably thought he was going to prison. And if you think you're going to prison, what do? That would probably have been good. Or you go on Twitter and tell everyone what you just did, right? And he said, look, can anyone get me a line with Coinbase, maybe the CEO? I filed a HackerOne report, but this is potentially market nuking. And that's not really hyperbole, right? Like being able to sell something you don't own and make gigantic profits. And Coinbase gets a lot of credit in my book. They immediately responded. They shut down the market for 24 hours. They figured out what the issue was. And it's probably one line of code, by the way. And then they blogged about it. And they said the root cause was a missing logic validation check in the brokerage API. And what that means is their API was checking the base size, the limit price, the account information. It just wasn't checking the product ID. Just assumed whatever you're selling is the thing that you own, which is actually not a bad assumption if the trade was coming from the UI, right? Because the UI, there's no button to sell your Ethereum as something else, right? But at the API layer, you can't. And this is the #1 reason why APIs are so appealing, right? My pro tip here is your UI is not part of security, right? It's a good Band-Aid. It covers up mistakes. But if the attackers can go around it, they're going around all those controls here as well. So that's my big opening thing. So let's dive into a few stats, right? We'll back up now. So 83%, that is what percent of the internet's traffic is API powered, right? This is a stat from 5 years ago from Akamai. They looked at all their traffic. It's probably even higher now. And it's really testament to how dominant APIs are. I mean, everything is powered by APIs, and it's for good reason, right? It's an incredible technology. But according to Gartner, API attacks now the #1 most frequent attack vector, right? And you'll see why here in a minute. And 4%, unfortunately, is kind of the state of API security. This is a survey from Nokia where they asked their users what kind of testing are they doing on their APIs, and only 4% said security testing, right? The other 96% is bugs and performance and integration and all this kind of stuff. And anyways, there's lots of reasons why that number is so low, but it's these three together are creating a perfect environment for bad stuff to happen. But it doesn't really explain why APIs. And so this is a very simple graphic, kind of, to me, tells the story. Like, APIs are this glue, the plumbing that makes the internet work, right? Whenever I log into my bank account, that's an API call. If I transfer money to pay my sitter, that's another API call. If I look up an address in Google Maps and then request an Uber, Google is sending an API call over to Uber, right? It's just this layer that makes the whole internet work, right? And you can see why it's so widely adopted, but you can see it's also like right there at the epicenter. If there's any flaws in those APIs, they can be exploited. And I have here, it can be easily discovered. One of the biggest myths that causes pain is believing that APIs are hidden and we don't have to worry about it. And you will see a bunch of examples where people made that mistake. And I'll show you how easy it is to find APIs. Here, I'm just going to United. I could have gone to anybody's website, right? And I'm checking some flights and fares and so forth. And if I want to find the APIs, I just right-click in my browser, go to the inspect, hit the network tab, and there you go, fetch flights, right? There's the API. You can see the command. If I go to payload, I can see the entire construction of it, right? Now, there's nothing wrong about this. They didn't do anything wrong. This is just how browsers work, right? All browsers really do is convert your inputs into API calls, right? So you can just get rid of the middleman and go straight to the API, right? How do I do it? You just right-click in your browser. And actually, this is part of what we're going to show later. We have a really nifty tool. But yeah, just right-click in your browser, hit the inspect tab, and then go to network. And then I just did a search for API, and there you go, right? There it was. It's not really rocket science. You don't even have to install anything. So let's describe how virtually every API attack happens, okay? You got your front end, talks through APIs to the back end, right? And I kind of put this box around the front end because we put a lot of security at the front. We do our web app scanning, we authenticate users, we control what you can see, what you can do, right? And so what attackers do, like you saw at Coinbase, they'll use your front end to discover the APIs. And the next thing they do is they just go around it and they start hitting the API directly. And if you think about that front end, it's a very controlled environment, right? I can only see what you show me. I can only press buttons you give me, right? But the API is a command line interface, and I can write anything I want and send it. And if the backend doesn't know any better, it's going to execute it, like selling Bitcoin that I don't own, right? And what they're looking for at that backend, and what they often find, are APIs that are over permissioned, right? APIs that can access more data, more functions. There are logic flaws that you can exploit at the API that you cannot exploit in the UI, right? And that's why APIs are so appealing to attackers. It's very much on the radar for auditors now. So if you're subject to PCI compliance, DSS 4.0 is loaded with API requirements. 3.0 had nothing to do with API, by the way. Wasn't in there at all. This is actually a finding from the FCC against Verizon, who owns TracFone. They were leaking subscriber data through APIs. They got fined $16 million for it. And beyond that, they were mandated to do continuous testing, prioritizing APIs to look for vulnerabilities with automated tools. Is that right? But the problem is, like, there aren't really great tools for that, right? Like, most API testing is manual, right? Or you use some old stuff like Nessus or something that doesn't really do much for APIs. Codem, they were here last time. So Okta is really more on the authentication side, yep, which is critical, but it's just one piece of API security, right? Authenticating is fine, but if I can still see your data, we got a problem, right? So that's the why, okay? So what's going on in the real world? So I spent a weekend a year or two ago, and I just tried to find every API breach I could find. And I ran out of room on the screen and ran out of weekend. There's so many examples, right? These are just the published ones, right? And there's easily double, triple this I could show you. And every one of these is an API breach. And what stood out to me is not just the sheer volume of examples, is these are like great big sophisticated companies, right? It's not credit unions and, you know, little ISPs. This is, you know, T-Mobile and Dell and, you know, Zoom, right? And they're not losing 100 records, 1,000 records. Like LinkedIn, 700 million records. The entire LinkedIn database got harvested, right? So something about API attacks are getting through the defenses, because you know every one of these had a WAF in place, probably had a SIM in place. They were doing code scanning, they were doing vulnerability testing, all of that stuff, and they still got breached. So here's what we're going to do. I'm going to take a handful of these and we're going to unpack them, and we're going to tie them to the OWASP top 10, right? So I used to like present this like, here's what OWASP 1 is, and that was like straight to sleep, right? So instead what I'm going to do is I'm going to give you an example of OWASP 1 and an example of OWASP 2 and so forth. So the first one I'm going to give you is from McDonald's. This is like 2 months old. And this is mchire.com. So if you ever want a job at McDonald's, that's where you go. And there's like a little friendly chat bot that will ask you questions, who you are, where do you live, what hours can you work. And it will, behind the scenes, send an API call to /API/lead/CEMXHR, and it will assign you a lead ID. It's kind of like an applicant ID, right? In this case, these are researchers, they're very well known, Ian Carroll. Their applicant ID was 64,185,742. Okay, so remember the 742, right? So they're like, great. And then just like a good hacker, next thing they did was get rid of the UI and start sending API calls direct. This is what it looks like. And they did a request for a lead ID, but they didn't look up 742. They looked up 740, which is not their lead ID, right? And there you go. There's lead ID 740. It belongs to Ida Portillo Lopez. They blacked out all of the sensitive bits, right? But it actually worked. And there's 64 million more that they could have done that to, right? With all of their PII and everything in there. There are many more examples, trust me. We're just tip of the iceberg. That is OWASP number 1, BOLA. This is the most classic example of broken object level authorization. It's number 1 for a reason, right? You can see the harm if you have this. It's actually super easy to exploit. All you got to do is change a digit, right? It's all about object references, right? Yeah. So for some reason, so OWASP has the regular web app top 10 and then the API top 10. In the web app top 10, they call this IDOR. And in the API 10, they call it BOLA. It's pretty much the same thing. It's an object reference at the end of the day, right? In this case, it's a user ID. And yeah, so OWASP 1 can user A access user B, right? OWASP 2, the example is Duolingo. I bet we have some Duolingo users here. I'm a Duolingo user, or I was, and 2.5 million records were exposed. So there was a researcher, they found all these API calls, and the APIs were wide open. Like literally the door is unlocked. Anyone can come in and use them and do whatever they want. And one of these APIs would accept an email address as an input. And then it would return back info about that user if they were in the system. So when I learned about this, I tried it on myself. And I didn't even have to like open a terminal or anything, right? All I had to do was go to this URL and put my email address. I just took a straight screenshot. This is nothing modified on this. That's actually my email address, and this is actually my account. And you can see I was trying to learn Italian. I had a 600-day streak. You'd think I'd be fluent. Well, I'm not. But like I could have put my neighbor's email address, my kids, Michael Jordan, anyone.
Your whole contact database.
Absolutely. That's how you get 2.5 million. You just guess, right? And the shocking thing is Duolingo's response was like, there's nothing valuable here, right? There's no home address or anything. By the way, it doesn't work like this anymore, although there is a difference between a valid email and an invalid. So you could still learn that. It just won't give you all this info. So this is OWASP 2 broken authentication. It's also OWASP 1, by the way, but just leaving the door wide open, right? There are so many examples of APIs that have no security on it. Literally, anyone can query it anonymously without credentials. So obviously, sorry? They didn't want to pay me about it. I didn't discover this. I'm not that good. Yeah, I hope so. You know. All right. So Venmo is my next example. So it's kind of a social payment platform for some reason. I don't get why anyone would want to know that I got my haircut last week and paid my barber or something. But here there was a feature on Venmo's homepage that would show you in real time, like the last 10 or 20 transactions, but anonymized, right? So it might have my first name, but no last name or anything like that, right? But this attacker saw that it was a public API and no controls on it, okay? So another example of an API with no lock on the door, okay? But here's the key. When the, wrong phone. So when the attacker queried the API directly, it did not return anonymized data. It returned the entire record, right? First name, last name, transaction. They even made websites to track drug dealing on Venmo by looking at the description field using this API, right? So he harvested 200 million transactions out of Venmo in full, complete detail, everything, right? And so my pro tip here, it's kind of related to the first pro tip, which is do not filter data in the UI, right? They probably just made this generic API that returned the whole record, and they're like, hey, developers, take what you need and just throw away the rest. But of course, when the attacker got their hand on it, they didn't throw anything away, right? And that is OWASP 3. It's a complicated one, broken object property level authorization. Some people call it BOPLA. They rename these things. It used to just be excess data exposure, right? Which is what this is. We have an API returning way too much detail. Do not need to do that. They should have made a special API just for the use of the homepage that only return the 3 fields that it needs and nothing more. All right, next example is Trello. So there's a feature in Trello where I can invite you to my project, right? I give them your email address, and some backend process will send you an invitation, right? Turns out that backend is powered by an API, as it should. That API was public and also unsecure, right? So the third example of an API with no credentials on it, right? So, but just like Duolingo, when you send an email request into the API, it will reply back and say, is this a Trello user? And all this detail about the user, right? So they're like, this is great. All I got to do is just guess email. So they went on the dark web and they collected 500 million email addresses from other breaches. And they sent 500 million requests at this API. And they found 15 million matches. And what you see here is the posting on the dark web, putting that data up for sale. I've got emails, username, full name, account details, right? That is OWASP 4, unrestricted resource consumption. Whenever we see brute forcing and millions of records, that's what this is, okay? So who here is wondering how the heck you don't notice 500 million requests coming through?
You do when you get your AWS bill.
Good point. That's a good point. Not their problem. Don't they have rate limiting? Don't they have a WAF in place? Don't they have bot detection? And the answer is yes, they had all of that, right? And they still got 500 million requests through, right? And the reason why is they'll obey every guardrail you give them. You have a limit, rate limit of 1,000 requests a minute. They'll do 999, right? And then they'll do it over 10,000 IP addresses, and they'll use residential proxies and all these things to evade detection, even to the tune of 500 million requests. And by the way, they have all the time in the world. They don't have to do this now. They could do this over 6 months, right? And meanwhile, your WAF has 2 milliseconds to decide if a request is good or bad, right? So what did they do? This is from Trello, right? We made a change so unauthenticated users can't access authenticated user data. All that means is they lock the door, right? Now, if you want to come rummaging through this API, you have to identify yourself, right? Well, you'd have to create 10,000 fake identities or something. It's a lot easier to have 10,000 IP addresses anonymously sending stuff, right? So, yeah, you're just making it harder on the attacker. But yes.
The guy doesn't care. Like if you have 10,000 contacts, it wants to find all of those people to invite. So
well, but
the limit's gonna be pretty high.
Well, but like if I log in as Dan and I want to invite 10,000 people to my Trello board, probably going to trigger something, right? As opposed to I'm going to log in as Dan and then I'm going to create another account as Ted and another one as Miriam, and I'm going to send 5 here and 5 there. Like it's just a lot harder, right? It's not perfect, but it's an improvement, right? All right, I got 2 more examples, right? This is from the dating site Bumble. They kind of got, I don't know, they have the bingo card of OWASP. They had OWASP 1. User A could access 100 million users' info, all of it. Even if you marked your contact info as private, the API still had access to it, right? OWASP 2, broken authentication. So APIs were wide open, unsecured. They had OWASP 3, excess data exposure. You could actually create 3 accounts and it would tell you the distance, right? So you could triangulate and find the exact location of any user on the dating app. But what makes this OWASP 5, which is broken function level authorization, is they didn't just expose data that a user shouldn't see, they exposed functionality that a user shouldn't be able to execute, right? So in Bumble, it's a freemium model. So there's a free account and a paid account. And there's an API where you can look up what kind of account you have. That would look like get/API/account type, right? That's fine. But they also expose post, which means I could say post to /API/account type, user type equals admin or paid or premium or whatever, right? You could change your account type through this API without making payment, right? And that's a function that an end user should never have access to, right? Only the backend should do that after I make payment and so forth. And then the last one I want to give you is, it's actually kind of one of my favorites, if you want to call it that, because it reinforces this concept of business logic vulnerabilities. So this is Instagram, and say you wanted to take over LeBron James. I always try to pick a local. LeBron James's Twitter or Instagram account. Here's how you do it. You go to Instagram, you pretend to be LeBron James, and you say, I forgot my password. And it would send a 6-digit code to the real, I always use Taylor Swift, to the real LeBron James, right? You would not get that 6-digit code, right? But it turns out there's an API where you can submit your guess, right? And so all you got to do is start, that's 6-digit, that's a million combinations. You start at 0 and you just work your way up, and eventually you'll get the right code. But of course, there were guardrails. First guardrail was a 10-minute timeout on the code. So if you didn't get there in 10 minutes, you're out of luck. But this is Instagram, right? Like a million API calls, no problem. You can do it. Guardrail number 2 was 200 guess limit. So after 200 guesses, it didn't let you do it anymore, right? But yeah, 200 is too many, right? So So they thought they were done, but they tried one last thing, which was they rotated their IP address, and it gave them 200 more guesses, right? So all you just got to do is just keep changing your IP over and over and over again, or just parallelize it over 5,000 IPs, and you can get through all million combinations well within 10 minutes, and you can take over anybody's account, right? So this is OWASP 6, unrestricted access to sensitive business flows. In this case, the sensitive business flow is password reset, right? Or it could be concert ticket sales or whatever it is, right? And the takeaway for me is, like, as developers, as product owners, we tend to think, does the app work as we want it to work? And in this case, it worked perfect. Nothing wrong with it, right? If I forgot my password, I can tell them I forgot it. It'll send me a code and I'm back on my way. But the way they implemented it created its own vulnerability, right? There are a lot of things they could have done differently in the way they implemented it. Number one, IP address is totally irrelevant, right? I don't know how that ever entered into the equation, right? You should get 200 guesses, period, right? Number two, 200 guesses is too many.
10 guesses.
Exactly. 200 guesses is too many. If I don't get it right after the third time, I'm going to be like 6, 8, right? It should have been 4 or 5, and then you retire the code. It's no longer valid, right? You can't brute force it. And then number 3 is stay away from incremental IDs, right? That should be its own OWASP, right? By making it an incremental ID, they're basically saying, hey, attackers, it's somewhere between 0 and 1,000,000. Good luck, right? If they put like a J in the middle of it, right, or an asterisk, or just make it alphanumeric, it's almost impossible to brute force, right? And so use your UUIDs and complicated codes, right? You ever notice when you get a coupon or like a voucher or something, it's always something complicated, right? And this is why. So that's it. In the interest of time, I'll skim through the rest. We do have courses on OWASP Top 10. 7 is a new one they added last year, server-side request forgery. This is all about tricking your server into going somewhere it doesn't belong, right? So let's say you have an API, you ask the users to create an account, and they give you their email and their address and phone and whatever, but for some reason you also want their LinkedIn URL, their profile, right? So you're expecting it's going to be a URL that starts with linkedin.com, right? But they might put something else. They might put a malware site, right? Or a SQL injection, or /localhost etc password, right? If it doesn't start with linkedin.com, you throw it away, right? That's called input validation. Pretty basic stuff, but people get it wrong, right? Don't trust what's coming into your API. Number 8 is kind of the kitchen sink of basic stuff. Security misconfiguration. So using patching and hardening and turning off services and using encryption, having rate limiting and non-revealing error messages and all that kind of stuff. 9 and 10 are kind of related. 9 is inventory management. So knowing your API footprint, right? You got to know your API footprint, but it's also about version control, right? So imagine you have like acme.com/API/v3, right? Pretty standard kind of path. Attacker sees that, they're going to try v2 and v1 and QA and UAT and anything else they can guess, right? And a lot of times those older versions hang around too long, right? You have that one customer that won't upgrade, right? And those old versions don't get the same security scrutiny. So make sure you're retiring APIs. And then 10 is the reverse, third-party API risk. So you're using APIs from DocuSign or Salesforce or Stripe, right? Just because those APIs come from someone else, don't assume they're safe, right? Do your input validation, do your testing. All right. So threw a lot of info at you, a bunch of examples, the whole OWASP Top 10. So what do we do to secure APIs better? And to answer that in some sort of methodical way, we went back to this list. And we analyzed every breach, and we tried to categorize. What was it? Was it broken authentication? Was it injection attacks? What was it? And we added it all up, and this is what the data looks like. And right away, you can see, just by eyeballing it, like the top 4 really dominate how APIs get breached, right? And right at the top is rate limiting. Almost 70% of the breaches involved kind of a brute force attack that didn't get prevented, right? And you might say, all right, we got to do a better job of rate limiting, right? Prevent millions of records from getting harvested. But I think it's the wrong conclusion, because just look at Trello, right? They had rate limiting, right? They had a WAF, they had bot detection, and they still got 500 million requests through. Rate limiting is basically a speed bump, right? It doesn't stop you from getting there, it just slows your progress. But we know attackers are determined and they can evade detection. And so, and this isn't the root cause anyways, right? If there was nothing interesting at Trello, they wouldn't have sent 500 million requests, right? This is just saying the defense is not perfect. So what is the root cause? And this was really eye-opening. Here we go. The next three, which I call the big three, were responsible for 90% of the breaches, right? OWASP 1, 2, and 3. And my takeaway from this is, if I do this talk for a lot of development teams, I'm like, if all you remember out of this talk is what OWASP 1, 2, and 3 are, and you make sure your code is solid against that, you have just defended yourself against the majority of API attacks, right? And what is it? OWASP 1, can user A see user B's data, right? That's just an authorization rule, right? OWASP 2, authentication, right? Are we locking the doors on our APIs? And then OWASP 3, excess data exposure, right? Are we revealing too much information? So make sure you're tackling this. So, all right, let's talk about, as I get sort of to the wrap up here, let's talk about the approaches to API security. There's really two approaches, main approaches: testing and monitoring, right? So let's talk about each one of those. So let's start with monitoring. So why didn't the WAF stop all those breaches, right? Not one of those breaches was prevented by a WAF. And the reason why is API attacks don't look like attacks, right? And I'll give you an example. Here is a request to get user ID equals blank or 1 equals 1, right? This is the most basic SQL injection that there is, right? 1 equals 1 is true. It will always be true. It will never not be true. No matter what the rest of this says, it's always going to be true. We have an OR statement. So if you're vulnerable to this, it's just dumped your whole user database, right? Nobody gets breached through this. And the reason why is WAFs will always catch this. It's very obvious, right? None of those breaches was a SQL injection. 0. Okay, how about this? Here's a request from user 10 to delete transfer 1, 2, 3, right? So let's unpack it, right? You've got user 10, let's say they're authenticated, right? They got a valid username, password. Delete is a valid method, transfer is a valid endpoint, and 1, 2, 3 is a valid transfer ID. But imagine that transfer doesn't belong to user 10, belongs to user 11, okay? Your WAF doesn't know the difference, right? Your gateway doesn't know the difference, right? This is just, they're looking at it and they're like, this looks like a perfectly fine request. It meets all of the requirements of sending a request. And that's the fundamental problem, right? API attacks aren't these brute force things. They're actually using your app in ways it's not meant to be used. It's at that logic layer, right? So that's the challenge of doing it in runtime. So let's talk about testing. The problem with testing is the vast amount of scenarios that you need to worry about, that you need to test for. I put security testing at the lowest level, right? Do we have unsecured endpoints, right? Door unlocked. Are we using incremental IDs, right? Are we doing our input validation like we should? Then we got on the data side, what kind of data is our API returning? Is it useful? Is it valuable? And then the logic layer is the hardest, right? Can I sell Bitcoin I don't own? I see my neighbor's Duolingo account. Can I give myself premium access on Bumble, right? These are your personal 0 days, right? And these will never show up in a CVE report, right? Like what happened to Coinbase can only happen to Coinbase. It's in their logic, right? So this is kind of interesting because I was here a month ago and there was a talk. And in it, the guy talked about shift left and shield right and all this stuff, right? So if you look at testing and monitoring, well, monitoring can only help you in production, right? When your API is live, it's under attack, right? Testing you can do anywhere you want, right? And shift left testing means you're testing for security left of that vertical line. And the speaker stood here and said, shift left is dead. Do you remember that? Right? I didn't want to pick a fight. But I couldn't disagree more, right? He said you can't do it in shift left because only in production do you know what's really going on, right? What the real situation is, right? And to me, that sounded ridiculous because we shift left lots of things, right? We would never push to prod without testing for bugs, testing that it performs, testing that it integrates. The only thing we don't really shift left is security testing. And it's not because we don't want to, right? Who wouldn't want to do that? If you have a vulnerability in your code, you surely want to know it. The only reason is it hasn't been feasible to do it. There haven't been tools that really do a good job of it. So that's maybe the segue here. There are really three main approaches that we see out there to API testing. Option one is do nothing, which is more common than you might like to think. Option two is do it yourself. So you got a red team, offensive security, something like that. And they're going to use tools like Postman and Burp and Zap, which are awesome tools, like really incredibly powerful, right? But you have to really know what you're doing, right? You got to know how, they're so powerful. They have a million knobs on them, right? And then not only have to know how to use it, you have to know what you want to simulate, right? Remember that all those categories, all those things, right? And then your engineers will keep releasing code and you have 50 different APIs. Like, how do you keep up? And option three is you pay someone else to do it. You hire a pen test firm once a year. They show up for 2 weeks. You're like, test everything, right? We won't even give you documentation or anything, right? And you think you're good because you got a clean bill of health, right? Or a couple of minors, right? And then they go away for a year, right? Does engineering stop releasing? No, of course not. So none of these are good. And this is the pivot. This is what we do, right? We've built this technology that analyzes your APIs. It's very smart. It's very intelligent. It understands your logic, your workflows, and it will build all those scenarios for you. And that's what Jesse's going to talk to us about. And the thing that I told you is sort of new here. And I'll give a demo of it here in just a sec. We just launched this yesterday, right? It's totally free. You don't have to pay for this. And it's called Bolt. And we know one of the biggest problems is I don't even know what APIs I got, or I don't have any documentation on them. So with Bolt, you can see it's a Chrome extension. You can literally fire it up and watch any website you want and see all the API calls. And it will even spit out an open API spec, right? So yeah, if you're interested, in fact, well, I don't know if you're going to be showing it or incorporating it. You can scan that thing. I promise it's a safe QR code. I always feel sheepish showing QR codes at security events. Last thing, I'll just pop through this quick. We can move on. I do a lot of auditor talks, right? And they always want to know checklists and questions they should ask. And I tried to keep this really condensed to like the really core things that you should look for. At the top, you got the big three. Then you got one on inventory, so knowing what you've got. Governance and risk, which is really about processes. And then at the bottom, education, right? And one thing that we do a lot, we do these talks a lot for organizations. So if any of you want a talk like this for your company, it's October, Cybersecurity Awareness Month. I was just in Dearborn doing one for Ford. We do them virtually. There's no charge. We don't charge for this stuff either. So keep that in mind if you're interested. And that's it. Okay. So I want to give you a quick demo of that Bolt thing, right? I'm really excited about it, and mostly because the reaction people have when they see it. It's super cool. So let's give it a try. And any of you can sign up for it. And the only caveat is we want your feedback, right? It's in beta, if you will. And we just want to make it as awesome as possible. So let's find ourselves something to test. Anyone want to suggest a website? Sorry? Well, it has to be a site where you can interact. Can't just be like, look at this page, look at that page. It's got ChatGPT. Oh, let me, thank you. Let me go back to Zoom and share a different screen. I don't know about ChatGPT. We can try it. Let's go to OpenAI. And, all right. Give this, am I logged in? Nope. I have an account, but let's, I don't know. All right. So, I don't know. Are the Dodgers, oh wait, I got to turn on Bolt. So here's Bolt, right?
How do we get Bolt?
So there is, yeah. Trying to think what's the best way for you all to get Bolt.
Can we get it from API?
Well, it's not in the Chrome store, so I got to give you access to a Google Drive.
What about?
You can scan that code that we just had a minute ago. If you go to, well, I can send the link out, but how would you all get it?
Just type it into our browser and we'll download it.
You can write this down.
Yeah, okay.
It's, let me, can I make that much bigger? There, can you read that? Oops, there we go. I'll leave that up for a second, right? Oh, and I can make the QR code. If you want to do it that way, you can also do it that way. So that'll just ask you to fill out a form, and then I will send you a link to the Google Drive. You'll have to ask. Unfortunately, Google Drive doesn't do public folders, so ask for permission, and I will give you permission. So sorry for a little bit of the runaround, but that's how you get it. And then I'll walk you through how to actually install it. All right. So does everybody get this if they're interested? Everybody get the link? Okay. Right now, it's only for Chrome. We will support others. You said, yeah, so I'll get your email. Basically, that gives me your email address, right? And then I will, the other way I could just show you the actual, I don't know if this is, it's too complicated to write down. This is the actual Google Drive link. I don't know a good way to send that to you.
Okay, I got mine in there by request.
All right, so when we transition, I will approve all your things, okay? All right, so let's try it on ChatGPT. So I just launched it. We actually have two modes. There's traffic and documentation, right? So traffic is just going to watch the traffic on your browser. And documentation is just another way, like if you find a documentation page and you just want to scrape all the API details out of it, it will auto crawl and do that. But let's just focus on traffic. So you got to give it a base URL, right? And so maybe you're not interested in the whole ChatGPT website. Maybe I just want, you know, API.chatGPT or something. But I like to leave it kind of wide open. So it'll get www and anything else, right? And I'll go ahead and hit start. Now, let me clear my memory here. So right away, sorry? Did they win? Dodgers won. So it's over. Oh, wow. How come there's no like fires going on in this? Yeah. 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 They're waiting for the big fun. How many innings was it? Oh, it was in 11. Wow. So you've been holding back. Right up. All right. So what's interesting here is we're in ROM mode, right? So it's looking at literally everything. I haven't even touched it, and you see like all these things. And that's just my computer talking to random sites. So it's kind of interesting just to see that. HubSpot, Google, like, all right, interesting. But that's not what I'm here for. I want to look at base URL only. So now I'm filtering only on chatgpt.com, right? So let's just say, are the Dodgers, I don't know if we'll get anything here. It depends on the type of app it is, going to win the series, right?
There you go.
All right, starting to do something already, and I haven't even hit enter yet. So let's go ahead. And it looks like there's a post there. All right, we're getting stuff, right? Which one? Yeah, and so you can actually come in here and see details. Here are all the parameters, 14 different parameters. Where the heck did that go? It already slid down. There you go. Right? I don't know what all this stuff is. Probably makes more sense to a lot of you, right? We have a 200 response in here. It will even give us sample code. Sorry if this is small for folks, but look, role as user. There's the actual command. There's metadata in here. Ugh. Right? Anyways, you get the idea, right? And so this is what it does. So it's actually found a total of 14 endpoints already and 138 parameters. This is actually a pretty fun example. I'm going to start using this. And so I can actually come over to parameter mode and it'll show me all the different parameters where they're being used. All right, so it looks like this one's being used in 2 endpoints. This param2, it looks like it's a UUID, base 64, blah, 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 right? And honestly, I don't understand all this stuff, but it's just a way to very quickly, you don't have to install or proxy or any of that complicated stuff. It's just literally inside this, it's all local, there's nothing phone at home or anything like that. And then the really cool thing is you can then, I'm gonna hit stop, and you can generate an open API specification, right? And let me show you what it just created. Where is it? Oh, wait, I can't do it in there. Let me open a new tab. And there you go. I don't know if you're familiar with Open API Spec, but that's what an Open API Spec looks like, right? And the really cool thing is you can actually take that and load it right into our testing technology. So that, I'll just do a little micro tour of that. This is what Jesse's going to show in a lot more detail. But all I had to do was press this OAS button. I don't know if I can't zoom in on that. This little button there, and that outputs an open API specification, which is the industry standard of documenting APIs, right? So all I have to do is just browse around and it spits it out. Now I have that documentation. This is what it looks like. It's machine readable, JSON. And I'm going to go ahead and let's just load it in. So I'm going to hit add application. Let me make this bigger. Whoops. I'm going to hit add application here. We're going to use Open API Spec. And I'll just call this ChatGPT from Bolt. And I'm going to drag that file in there. And there it is. So I just onboard it, and now it's going to rip apart that API, right? And it's analyzing it. It's building a model that understands the endpoints and the parameters and the payloads and all this stuff. And in that amount of time, it has now analyzed all that. Let me close Bolt here. We have 14 endpoints, as we already knew. This one isn't the most interesting because it's not doing anything like login events or transactions. So these are all low sensitivity endpoints. But the coolest thing is it also computed 2,000 different attack simulations, right? So when I showed you that thing about like, security and data and logic, that's what makes up 1,800 tests, right? And so you can automate this. You can actually rely on tools to do that. So that's the gist. I'm gonna pause there. Maybe we take a little break or something. But meanwhile, I'll get your, for everyone that's requested, I'll get your link set out. All right. Good. Should we break for a little bit?
Yeah.
All right. Thanks, everyone. And we'll switch over to Jeff.
Any audio? Good to go? All right. For the recording, forgive me. I'm Jesse Freeman. I'm a product implementation engineer for AppySec. What that means is I help enterprise customers and smaller connect their applications and APIs to our security scanning tool, platform, product, whatever you want to call it. I will. Yes, I will. Yes. Raise your hand if you understood everything Dan was talking about and you're really confident in how APIs work and like what they do. Sick. Okay. I'm going to give you guys an analogy to start. I did not prepare any slides. I'm sorry. It's mostly going to be talking and live demonstration. So an API sort of behind every API, behind every application, behind every payload, behind every security scenario is what? Good answer. A little bit of a trick question. Another great answer. Not the answer a hacker might give. Humans. Humans are behind all of it. It starts with us. None of this exists without us creating things in our mind and putting them in machines, right? So if you think about an application like a restaurant, the way that it works is effectively you go in as a user to this restaurant. Everything that the application can do happens in the kitchen, and the server is the API call. You give them your HTTP request, you give them your order, they take that to the kitchen, and then the kitchen decides whether or not they're going to make it, right? So the way a payload works is, imagine if I go into a restaurant and I order something off menu. And the waitress doesn't know any better a lot of the time, right? I could be a regular. I could have been ordering this for the last 10 years. She doesn't know. She's not going to argue with me, so she brings it back to the kitchen. And then somebody in the kitchen goes, we don't serve cereal here, dude. It's a Michelin star restaurant, right? And now the attacker knows, okay, they don't serve cereal here. I'll come back tomorrow and order something else. The difference is in an application, in a digital realm, this is happening 500 million times, 10,000 times a second, yada, 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 right? It's not a simple order. So imagine if you could have a machine as the waitress that you could put the order into, and it would tell you whether it was valid for the kitchen before it even got to them. So the guy running the kitchen doesn't even have to look at it, right? If it's a bad order. That's what AppySec is doing for you. Okay, and we do that by understanding your API, how Dan showed you, through an OAS or a Swagger file, or those are the same thing, by the way, if you ever hear people throwing those around. Swagger was replaced by OAS effectively. People still use both terms. They're effectively interchangeable, almost identical file types. YAML right up there too, very similar. But yeah, let's look at the product. So if we actually jump in here, I'm going to do a manual portion here too. So I'll show you guys what the actual hacking part of the things Dan was explaining looks like in a controlled, vulnerable environment that doesn't have a whole bunch of mess inside of it. And the main thing to understand about applications from a hacking perspective is that just like in restaurants, the quality, complexity, and resources available to the kitchen varies heavily from application to application, right? Meaning you could have 20 endpoints in an application, you could have 2,000. And if you're needing to run a payload against every single endpoint, whether you're checking for something like rate limiting or some other security header that's common, you're going to have to do that 2,000 times, or write a script that does it 2,000 times for you and then analyze that data, right? That's a heavy lift for a security team. And when you hire somebody like a pen tester or a firm to come in and test your application, what you're really paying them for is time. Right? You can write the contract however you want, but in reality, they have an hour to break your app, or a week, or a month, or whatever it is. That's what you're paying for. So one of the benefits in using something like AppySec is it creates a baseline for your application and security testing, meaning all of the time you have all of these tests running against all of your endpoints. So when that pen tester comes in to look at things, they have a really solid, I don't need to run any CORS testing, I don't need to do HSTS headers, I don't need to check for BOLA because they've had BOLA scenarios running all year long. Then they get to go off and play, because what the top level threat actors are doing is analyzing the order, right? The difference in an application is the order to the kitchen gets created by the app, by the browser. You're not technically originating that order, but what a hacker is doing is modifying it. There are pieces of the order that are not required to make your application do things. There are pieces of the order that can be mutated to make the application do things that it shouldn't. And that's exactly what was happening in all of the examples that Dan showed you guys. So let's see what this kind of looks like. Before I actually show testing in here though, you can see I have a whole bunch of applications loaded, multiple instances. This is my little team's private tenant with all sorts of different stuff in it. But the app that I want to show you today, some of you may be familiar with, is called Crappy. Anybody tested on Crappy before? Sweet. Maybe. Nice. Okay. But in order to look at what's happening in Crappy, we could do it this way, like Dan said. Look at network traffic and log in with something, see what it looks like. right? Here's my login request. You can see my response gave me a bearer token. If we look at my payload, you can see my email and the password that I typed in, right? Now, all of this data is traveling through the API. And you can see it in your network traffic. The way most people are used to seeing it in terms of security testing is through something like Burp or Postman, which looks like this. You can download the community edition for free. You're welcome to follow along with me during this if you want to. The base URL for this website will work for you, crappy2.appisec.ai. That's public. You're welcome to access that. Get back to Burp here. Go to Mozilla, but you can see the tediousness of it here. I already have my extension set up so I can route my traffic through Burp. That's no problem, right? And then if I log in here, hopefully this will work on this Wi-Fi. And we look over here, my HTTP history. Here's my login request. It's exactly what you saw over in the network traffic, right? But the thing that's awesome about Burp is it gives me tools like this. I can send it over to the repeater. And now I can, change this. What if I want to test a different password and change this to testing2 exclamation mark? Then what happens? Oh, it's a 401, invalid, cool, right? Intruder would allow me to do what I just did hundreds of times in a row with a word list of different numbers and passwords or whatever I want to replace, right? So this is the power of the hacker. They're able to manipulate these things in all sorts of different ways. So what can we do to Crappy? Let's find out. First, let me get this out of full screen. Hold on, because that's annoying me. All right. It is crappy2.appisec.ai. Crappy 2 and Crappy both work. The 2 is basically like a extra demo environment that not the world, the whole university doesn't know about this URL, so it's a little safer to test on. The other version that we host at crappy.appisec.ai is used by the university, and Corey Ball loves to call it a public restroom of an application. By 1 o'clock in the afternoon, there's graffiti on the walls and all kinds of nonsense going on in the database, so not super reliable. This one stays pretty reliable most of the time. Now, let's imagine that Crappy is actually an enterprise level application that we're starting to build, right? So when you start, you have to start somewhere. Maybe we started with the dashboard and then we added the login ability, right? We created the pieces of the code that allow us to make an account and log in and created those endpoints. And we have a bare bones website, right? And it's eventually going to be a shop. So we need to add the shop, and we're going to buy car parts, and those car parts are going to be related to our vehicle. And you see where this goes, right? All of these branching things. Well, we started with just logging in. And these days, a lot of applications are built on microservices, which allows people to have miniature teams of devs building little tiny pieces of applications asynchronously, and then all of those come together to make the full application. So if we imagine the shop and the community aspect and these vehicle details as different teams working on different microservices of this application, that is how these vulnerabilities come to be. Because when I start working on something, like the shop maybe doesn't start getting built until a year later. It's a year in development that we start adding the shop. And the developer who is building that might be brand new. And the team who's built everything else might have already left. You all work for, you know how tech works, right? So if I ask my boss, hey, what do I need to do for auth on this? And he goes, oh, they solved that at the beginning. Authentication is handled at the top level. Like, just do your thing, make the functions work, ship it to me, cool. Literally, conversations like that is how these vulnerabilities come to exist, because people aren't taking the time to break down into the nitty-gritty of each individual API call and verify that the logic happening behind the call is valid. Right? So let's see what that looks like in practice. You can see here I have this user, me, Jesse Freeman, scanner test 12. I own this vehicle here, right? And so only I should be able to see this vehicle. You can see there's some pretty interesting calls here. I can look at the location for the car, right? If we go back to our repeater, I hit that refresh button just now. Well, this is one of the things that Bolt is really awesome for, right? Because I don't really care about all this other stuff. I really just want to see what's coming from Crappy. So we can do stuff like, where is my scope, right? So let's just add Crappy. Now let's just add appisec.ai to my scope and include all subdomains. Okay, yes. We'll go back to our proxy. I only want to show in-scope items. Ah, that's better. Here's our vehicles. Oh, look at that. There's a UUID right there attached to my vehicle. And you can see there's a PIN code there as well. That's interesting too, right? What if, and then we have this location, and it looks like in that location, we passed the UUID as the value, right? Classic, like an IDOR scenario that Dan was showing earlier, right? Where you have like a user ID and a URL, and it's user 12, and you test user 13 or user 14. Well, in black box testing, that sort of where you don't know anything about the app, that makes sense. But what AppySec proposes is, what if you start with a call that's good? What if you know that everything's right? What if you have a valid piece of data, a valid object to access that doesn't belong to you? And that's what ethical hackers are doing on platforms like HackerOne, right? And we agree that you should do it that way, but you should also automate it. So if I'm gonna actually pivot for just a second and show you guys Postman. Postman operates a lot like Burp. It makes it a little bit easier, in my opinion, to like send calls and manipulate them and kind of read what you're looking at. If you're new, Postman might be a little bit cleaner for you. But we can see I already have the crappy API spec loaded into Postman, and these folders contain all of the different endpoints. And there's this vehicle location endpoint right here, which is the endpoint that we used. You can see the vehicle ID lives in the right here, right? Which is going to be this. And if we come back to Burp, we can see that that is the same ID here, 57C, 57C. Awesome. So that should only be accessible to me. What happens if, so I'm scanner test 12, here's scanner test 14, totally different account. Log in. This is me grabbing the bearer token that I got from logging in. And in order to send an authenticated request, you'll notice if we look at this traffic here, let's look at one of these guys down here. Nope, not that one. Where's one for crappy? Here, let me just do this really quick. Uh-oh. Did I make crappy unhappy? What did I do? That's okay. But effectively, every call that we send just has a header that says authorization bearer and has this token in it. And that's how the app tells who we are. That's authentication. Who are you? Authorization is what you're allowed to access. If we come at the top level here, I can actually look at this API and I can set up, here's my bearer token. So I'm going to paste that bearer token that I just got from the different account into my auth flow here. So now in Postman, in this environment, I'm operating as user 14 instead of user 12. Right? If I come back here and I send this same exact request, this is this. Same exact request. Right? We're still getting a 200 response. My exact vehicle ID and location information revealed. So effectively, any user in this application, provided they have your UUID, can find out your vehicle location. Now, while UUIDs, especially a UUID 4, version 4 like this one, is effectively impossible to crack. That's why it's highly recommended that people use them. But that's why OWASP, the big three, are the big three, because they work together. That's what excessive data exposure is for. Let's poke around in crappy and see if maybe we can find an endpoint that will give us a vehicle ID, right? Mm-hmm. So what I did in Postman here, let's go back to Burp for a second. You see how in this HTTP request, there's this authorization bearer field here? Yeah. This is your key to the door. All I did in Postman was tell the overall application, which is the foldered root directory here. I click on that, I clicked on auth, and then I pasted that token I got from logging in right here. And then what Postman does, if I look at any of these other endpoints, like the vehicle location I just accessed, if you look at the authorization here, you can see that I'm inheriting from the parent. And all of the endpoints are set to inherit that bearer token from the top level. And that allows me to quickly send authenticated requests as any user I want, provided I have the token. All I got to do is come back to that top level, replace this value with a token for whichever user I have the login info for, and I can now send requests as that user. Yep, you can, yep. Burp does, yeah, Burp will effectively do the same thing. The difference with Burp is I would have to, I'll show you actually. Yeah, no, please ask any questions you want. So are we in? Let's go back to, let's send this to the repeater. So this was our original request with our token from me, right, that I captured in Burp. Let's come back here, grab this again. Let's take this value here and just swap it out with the new token. Still got the 200 response. That's basically what I just did in Postman, just a different UI. So the reason that I'm showing you two tools and why I only listed one is because a really critical part of understanding what you're looking at in these HTTP requests, in my opinion, is being able to visualize the request itself outside of a technical space, outside of a screen or a UI, right? Because this is a really simple example with Crappy. You can see there's just a few handful of headers here, but let's try somewhere more just to show really fast. Let's look at ChatGPT. Network. That's a JS. I don't want a JS file. Give me an XHR in this one. Here. I'm just looking for an API call in network traffic. You can say anything you want. Here we go. So you can see when you're looking at calls being sent by an enterprise app, look how many headers are here. Just goes on and on and on. What do all these do? Good question. And that's primarily what threat actors are doing. This is part of the order that goes to the kitchen. And part of what a threat actor is doing is, like, one really common thing I do all the time is something I call header surgery. I'll just come in here and start removing one header at a time and seeing what I get a 200 on. Do I need content length? Do I need accept? Do I need report to? Because what you'll find is, again, what's behind everything? Humans, right? So when a human creates this, did they write the logic to say, hey, if somebody doesn't have the report to header in there, what do I do? They might have included the logic for what to do with that header, but if they didn't, you know what I mean? And applications, when they're not given instruction, will do weird things, weird things. And there's really no rhyme or reason to it a lot of the time. But just like Dan showed with the Coinbase example, like sometimes it's as simple as just changing a value and you're in the money. Okay, so let's talk about AppySec a little bit more now, because we're coming up on time and I want to spend time in the product. You've seen what it looks like to find a BOLA example in Burp now, right? Like a lot of what you saw Dan doing was BOLA, IDORs, things like that. That's how you hunt for it. We can set that up in AppySec too. One of the things that is an advantage in AppySec is because you're interpreting a spec, or we can actually take a Postman collection as well, right? Like Crappy has a bunch of challenges. What they call them challenges. They're vulnerabilities built into Crappy, designed for you to go hunt and find. If this is interesting to any of you and you want to go practice this stuff, go do it later. But in order to find them all, you need to configure each individual endpoint a certain way, right? We needed a login, we needed a vehicle ID. All of those things are essential to making it work, to running the test. And what AppySec is doing for you is running that test over and over in perpetuity, right? So if we onboard an application using, where is my, oh, where did I put it? Can somebody hum Jeopardy music for me for a second? There we go. That's the one I want. Okay. So this Postman collection I have is actually a pre-configured one that I built myself, and I'm happy to share it with any of you if you'd like to see this in action. This Postman collection, thank you. I appreciate that. So this Postman collection, I'm going to edit my base URL here because we're using Crappy 2, and if I don't, my database will be different and my tests won't work. So this Postman collection that I'm uploading has like 13 of the crappy challenges effectively pre-configured in it. All you would need to do is set up the auth profile, which I'll show you how to do here momentarily, which will again give you another understanding of what this HTTP request looks like outside of the box, right? So let's go set up some auth. For crappy, it's really, really easy. We're going to be using a bearer token authentication type. You can see we also support OAuth 2. Basic API key allows you to do any combination of custom headers you would like to. We also have custom auth. This is really cool if this is something your org is interested in using, because it allows us to effectively, like Postman, chain together any sequence of HTTP requests, extract data from them as we go, and wind up with a login at the end, right? With a bearer token or whatever we're supposed to get. Because with enterprise orgs, a lot of times it's like 6 different calls to get all of the headers and things that you need to actually authenticate with the server. Crappy, nice and easy. It's probably that one. Oh, where did I put it at? Oh no, that is it. Yep, okay. And then our test 12 at email, password. Make sure I type that right. Good. Advanced section allows you to add additional headers, body parameters. If your token expires, you can let AppySec know so that we make sure to refresh it before your tests start expiring while we're running tests. Content type can be adjusted here. Username key, password key. This is indicated by the application. In Crappy's case, we use an email key for the username. And that's important because it basically lets you, these are little things that we do in security, right? Like the defensive piece of it. Just giving it a username key makes it so that people can't just brute force random usernames that aren't emails. That takes a whole lot. When I'm talking about, let me just send something that shouldn't work and see what happens, those little guardrails are the type of things that really just slice that stuff from happening and knock out a big chunk of that defense aspect. Okay, so we'll test this. Why did that not work? Scanner test 12. Email.com. Oh, that's why. This needs to be crappy too. That's weird. Let's try a different one. Do user 2. Bearer token. Well, let's just do the 1 for now for time. I'll set the bullet scenario up if I have time. I want to know why this is failing to test. Is that the right? Bear with me 1 second, guys. I'm just going to make sure that my, oh wait, I don't need to do that. It's right here. Identity API auth login. Yeah, that's right. Auth login. Do HTTP. That looks good. Scanner test 12 at email.com. That looks good. Why is this not wanting to work? Username key, password, all good. I have to be doing something wrong here. Let's try 14 and see if it works. Could also be a network thing with the Wi-Fi. I'm not sure. Well, can I scan an endpoint? Sorry, I'll come back and do all this again. I'm just troubleshooting really quick to make sure my scans will actually fire. For the like auth profiles and stuff? Yeah, you could. You definitely could, yeah. Yes. Yeah. Yeah. So CI/CD is a really great question. A lot of people use us in different ways. The way that I recommend people use us is putting us right before you push to prod, effectively. Like build us in when you have a new release coming out, scan it with AppySec, and we can actually set up like GitHub Actions or whatever to like break your build and prevent it from going live if there's a vulnerability detected. Automatically send Jira tickets to all of your teams. If you look at the integrations page, you can see all that different stuff. We integrate with a bunch of different gateways. If you're using a gateway instead of a spec, Jira, Azure DevOps, GitHub is in the works. You can integrate with Slack and Teams. Jenkins and GitHub Actions are already supported. If the button is grayed out, it means that we can set it up for you as a customer. The UI just doesn't work yet. Yeah, there are some, I mean, if you keep an eye on AppySec, we innovate at a ridiculous speed. The application looks way different than it did at the beginning of this year. But yeah, CI/CD, popular and recommended. Go ahead, Dan.
Make sure everyone knew, if you go to appysec.a, you can get a free.
Yes. Yeah.
What he's showing you, you can get access.
Yep, you guys can do all this stuff.
Yeah, I'm gonna get you all these.
Okay, let me take a second here and see if I can figure out why this auth is not working. Oh, I deleted the I in crappy. Jeez Louise. Ay, ay, ay. Okay, sometimes it's that simple. So there's my bearer token now. And what AppySec can now do is effectively emulate this process, grab this bearer token and send it with every request, right? So let's go ahead and do that. Let's scan all of our endpoints with authentication as user one and see what we get. Right now, we have no vulnerabilities detected in the application, around 5,500 tests. We can actually look at this in real time. You can see there's some vulnerabilities already falling in here. We've scanned 4 endpoints so far, number of tests generated, number of tests executed, number of tests skipped. Skipped tests happen most of the time because we're not getting a 200 response from the endpoint with what we call a dry run, right? That's what the order is supposed to look like. It looks really good. And according to your documentation, we should get a 200 with it. If that doesn't happen, we can't do deep coverage, because what AppySec is effectively automating is the header surgery I'm talking about, manipulating your JOT token, a number of things. We can go through the categories here and you'll see. But what's really awesome is these categories actually break down for you. You can see exactly what was sent in the logs. You can see what your request body looks like. You can see we did an unauthenticated test just to make sure. We may as well make sure that it won't give me a 200 when I'm unauth, right? Dry run log 2 has our bearer token now inserted. We're now getting the 200 from this endpoint. Again, all of the headers we sent. If you would like the raw data, there's a little button up here so you can get it that way. No problem, right? And then if we look at vulnerabilities, oh, we've got quite a few now. But let's look at that in the actual application instead of the scan history page. Oh, we're going to have to wait until it's done, aren't we? Got that Jeopardy music handy still? No worries. While we wait for this to finish, any questions on anything so far?
Yeah.
No, please. Yes. It's not code analysis. No code analysis happening here.
We don't do code analysis because you really can't evaluate logic.
Right. Yeah, the best thing is when the application is done.
Yeah.
So
Outside testing.
Yeah.
Sure. No, you're okay. No, you're okay.
This is what I would call it, like your legacy data.
Yep.
I mean, like, it's gonna look for common things, right? I used to work at Qualys, so I know all about like CVE, common vulnerability entity, right? So like a SQL injection, a cross-site scripting, a buffer overflow, right? These things that can exist in anybody's environment, but what, as you saw, right? They can't really test for Coinbase, right? Where like I'm selling something I don't own, right? Cross account. This is a big thing. Like the legacy DAS, they don't really exercise APIs in the way that APIs get exploited.
So I have another question. How about standalone application? Does this work?
Does it work on standalone applications?
Yeah.
Of course.
Does it go out? Is there an air gap?
Oh,
Yeah.
if it's, like not internet connected.
Yeah, you would set
Go
up,
ahead.
so you'd set up a hosted agent. So you can see over here on the, I'll show you in just a second. But effectively, it's a Docker container that we deploy inside your network that allows us to route all traffic out to public through a controlled way, like the way that you guys would need to, or we can do on-prem as well, if that's mandatory, either option. Yeah.
They're not going out to any.
Yeah. Then you, sounds like you might need on-prem for that one, which is possible, but is a heavy lift. Okay, same password. Just setting up a second account while I wait for the scan to run really quick. Change this again to email. And I forgot to update the base URL again because I never learned from my mistakes the first time. There we go. Just kidding. Why is it doing that? There we go. Okay. Awesome. This is almost done. So let's talk BOLA and AppySec really quick while that finishes. I've got a few minutes here to show you guys this. BOLA testing in AppySec, our business logic suite, in my opinion, is one of the best things about AppySec, and it's what really sets us apart from our competitors. Competitors are looking for standard web application vulnerabilities, typically, even with their API tools. I won't name names and throw people under the bus, but I've tested many of our competitors, both their web app tools and their API tools, to see. And in my experience, there's a lot of false positives on the API side. And for the most part, it's almost a direct copy of the results you get from the web app scanner. In our case, we're doing things a little bit differently because we're not just sending a random payload in these cases. We're actually going to be sending payloads as two different users and then inferring things based on the results of those two separate requests automatically and alerting you if something happens where one user has access to something that they shouldn't. So let me show you what that actually looks like. We're going to set up that vehicle location one that I showed you guys earlier. Right? We're going to select both users for this scenario. We're going to select a resource. We're going to search by endpoint. This is the endpoint I want with the vehicle ID. You can see because I used that preloaded Postman collection that the value I want is already in there. I know that user one is the resource owner, and I know that user one should be the only one with access to it. This gives us an option to choose additional endpoints if we'd like. So let's say there were like 4 more get endpoints that all used vehicle ID. We could use all of those as well in the same scenario and check all of those endpoints for BOLA vulnerabilities. We'll test our scenario. Gonna load for a second. It's running dry runs right now, making sure the endpoint is configured properly. Boom, ready status is awesome. We can enable it for scanning. Now let's go take a look at those vulnerabilities. 27 vulnerabilities found. We have NoSQL injections. We have unenforced credentials, token tampering, SSRF, PII information leaks. So like, here's an interesting one. Community posts. Oh, there's IDs in community posts that probably shouldn't be there. What else? What else is in here, right? Incremental IDs, so it'll actually alert you if you're using incremental IDs. That is considered a medium finding. A lot of people argue with that, but the fact that an incremental ID exists in your API, even if intentional, is a medium risk. The reason for that is if a token were to be compromised, people are having a heyday, right? They're going to run through those incremental IDs. Okay. Now, when you're actually verifying and validating, right? Because you need to have some sort of semblance that these findings are real. How do I know? Well, AppySec will tell you. Let's look at our dry run log. We can see here, your endpoint responded with a 200 status code. This indicates we were able to successfully run it, and your data is likely at risk. And if we look at the test log that's being highlighted, no bearer token being sent, still getting a 200 response code. And so AppySec is able to tell, hey, when you uploaded this spec for this endpoint, it says authorization is required. Authentication is, is required. When we ran it without any bearer token, we still got the 200. That means that authentication is not enabled on this endpoint that your spec says that it should be. We're going to alert you to that. It pops up right here. If you were in pipeline, it might send a ticket to the team automatically in Jira that needs to go find the code that's responsible for this issue and remedy it. right? We're also doing a little more advanced stuff too. This in particular is another thing that I don't think a lot of other tools do well. Token tampering. We're messing with algorithms. We're trying to crack your secret. We're doing all sorts of different stuff with tokens that's a little bit more advanced than our competitors typically do. Yeah. So we can see though, we set that Ebola scenario up and we don't see the detection. And the reason for that is because we didn't have it set up before we ran the scan. We got to scan it. So let's go ahead and just scan this one endpoint really quick. We don't have to do everything, right? You can also create scan profiles, which allow you to choose a subset of endpoints with the authentication, excuse me, that you would like to scan it with, name it, right? And then you can set up scheduled scans that will run weekly, daily, whatever you want, and they will utilize those scan profiles that you've built, so you have a really good inventory of exactly when and what scans are being run. We've rescanned that endpoint now, so let's take a look. Do we have a... Boom, broken object level authorization. This is the threat detections view. I was showing you the vulnerabilities view. Threat detections will basically bucket all of those vulnerabilities into their respective categories for you. It's just a little bit cleaner. And here's our Ebola vuln. We found that user 2 was able to access the data that belongs to user blah, blah, blah endpoint, right? And so we can see now that they have the vulnerability. We know, AppySec rather knows that user 2 was not supposed to be able to know this. How does it know? Well, because we told it. The same way that you would tell your penetration testing teams, right? That's effectively what you have here is like an AI-powered pen testing team. You give them the instructions on exactly what tests you want them to run, and they run it all the time, every day, right? Pretty awesome stuff. And then from here, you know, there's lots of other things. You got your security hub, which will give you, this is going to be a mess because I have like 400 broken applications in this tenant. But what it'll do in a normal tenant for you and your applications is show you trends. It'll show you how many tests are being run, how many endpoints we're scanning, how many vulns there have been, how many have been remediated over time by your teams, so that, you know, like people at the CISO level can look at this information and have an idea like, oh yeah, my program's actually working. The proof is right here in the pudding. I can see last month we had 200 open vulns. This month we have 100. We're running as many tests as we did last month, so I know our coverage isn't drifting, right? They're able to infer all of this stuff about their program by the data they're seeing here. And you can imagine, like, this is crappy is, you know, what, 20 or 40 endpoints or something like that. But like, what about an enterprise org with 2,000 or 10,000 API endpoints and 1,500 different objects that are potentially vulnerable to Ebola attack and all of these different things? It's an extremely large lift, and that's why with traditional pen testing engagements, such a massive part of the time spent is doing the stuff in burp that I just showed you to validate that those vulns aren't there, and setting up, you know, doing Bola and burp. You can see like the lift in AppySec to get that set up, so much more streamlined. You know exactly which users are involved, and you have profiles for them. You have a list of the endpoints, and you can actually like filter them really quickly to see if there's other ones that are relevant to this resource, right? It's teaching you about your application, and once it's set up, you never have to touch it again. You don't have to even look at the results if you're safe, because AppySec is letting you know you're safe by not populating your vulnerability. All right, we're coming up on 8. I've shown a ton of stuff. Is there any questions? I want to wrap up for you guys and let you get on to your evening. Sure. Yeah, within AppySec? Yeah, so the, helps if I go to the right level, right? So we filter by sensitivity currently, readiness. Method is currently not a filter option, but like you can do it this way. Just type in put or post or whatever, and it'll filter it for you like that. And I'm sure we'll probably add that in the, you know what I mean? Like the way that our feature releases go, honestly, is like people ask us for stuff. We're like, oh yeah, good idea. We put it in, and a few months later it pops up. And for our customers, especially, if you need something, our team turnaround time is unbelievable. You had, yeah. Sure.
And no way devs can fix everything. Okay, so do I just look at the red one, say, hey, that would be something we should
That's a great,
We can't, never fix it. Okay. and you-
yeah.
Means higher rent.
Yeah, so red is critical, right? It's a critically sensitive, and this here is letting you know that this endpoint is critical because of either it's authenticated, because it has sensitive parameters. In this case, this is what we're looking at. There's obviously an ID being used here that matters, so sensitive information, right? Now, in terms of the remedying aspect that you were talking about, like, yeah.
It's scam and you get 10,000.
Yeah, 10,000, right?
Right?
There's no way I can.
This is the biggest complaint that people had about the.
Yeah, there's a lot of false positives.
Yes.
You never gonna fix 10,000.
Well, yeah.
And if you really had 10,000 vulnerabilities, why is your like eating up, right? Like they're clearly not real, right? And so this is different because what we're doing for attack simulating, what it means is like there aren't false positives anymore, right? And we also don't generate 10,000. It's going to be really like tailored. So if we found it, it means it's exploitable,
Okay,
right?
right.
And the critical means it's happening on a critical endpoint, right? So like if one of these endpoints was check the weather, it would be low, right? If one of them was transfer money, then it would be critical, right? So it's actually looking not only at what the vulnerability is, but what's the functionality that it can.
And how do you guys get that functionality?
So where there's some ML in the background, like if we look at the parameters and there's customer ID or transaction or login or token, right? We're using that kind of, when we say we build a model, it's actually all that kind of stuff in there, right?
That's our secret sauce. Yeah. No, it's, yeah. So, one of the things I love to tell our customers is when like our product is incredible. The reason that I joined AppySec was because their product blew me away in February, and it's way better now than it was in February. But our team and our support is really where we shine, because API security is pretty new, and we've helped enterprise orgs, dozens, hundreds maybe at this point, prop up brand new API security testing programs around this product, right? Which means I'm learning about people's applications, I'm learning about their auth flows. I teach security people and developers about their own applications every single day at work because of AppySec. Because AppySec forces you to understand your own application. How do I auth? Like if you work with devs on an application, I encourage you to ask one of your developers how your auth flow works and see if he just knows. I would wager he probably doesn't. I've had enterprise orgs ask me to figure out their auth flow. They send me an HTTP request and they're like, dude, we don't know what of this is necessary for auth. You figure it out. And then I have to go do that so I can build the flow in AppySec so they can start testing. Go ahead.
There must be examples from city, state, governments,
Yeah, we have several government customers. Yeah,
major problems,
sure.
just as a regular citizen. I mean, we're probably all vulnerable to all the bad government.
Well, it depends on how you look at it. I think that government actually tends to be one of the more secure areas simply because their architecture is old as dirt. Straight up, they got Cobalt and all DOS and all kinds of random nonsense nobody would touch in 10,000 years running underneath those APIs. And figuring out what your payload needs to look like to actually make those old technologies do something impactful is tough. That's high-level hacker.
So if you ran the LA County Assessor's Office website right now.
Yeah, I mean, something like that is probably going to be basic. You might find like an SQL injection. There might be some excessive data exposure going on. It's possible, but highly unlikely, I would say. Those guys are typically pretty stringent about those types of things. And I would wager that if you found something on one of those websites, it would probably be extremely low impact. Because here's the thing, right? Like some endpoints in applications will be designed to expose excessive data. In a banking application, when I am retrieving my bank account, I need the balance, I need my name, I need the account number. All of those things have to be in that call. There's no way around that. Otherwise, how am I supposed to know what's in my bank? Right? So you have to think about it like that too. It's a matter of security is a balance between safety and design. Usability and security. Those two things are always at war with each other. And the goal in shifting left is that those two things come together from the very beginning versus trying to come after the fact and apply security to something that was, built with holes in it from the very beginning. And the reason for that, or a caveat of that, is the longer you wait, the more complicated it is, especially if there is old architecture involved. That same process of figuring that out and going back and fixing it is just as long and tedious, maybe even longer and more tedious than figuring out the payload to execute to make your attack work.